Hi there, Mr. Sutton here, bringing you the IM3 1.4 Extra Practice Solutions on Systems of Equations word problems. On this problem, we have Keith with 18 coins that add up to $4.05, half dollars and nickels only. We want to know how many of each he has. Let's start by defining variables for the things we're solving for. Let's say the number of nickels, we'll represent that with just n for lack of creativity here, and we'll let h represent the number of half dollars. So we're going to have to set up some equations using these variables. We know that there's 18 coins, so we can set up an equation that talks about the number of coins. If we add the number of nickels and the number of half dollars together, we ought to get 18. So we can say n, the number of nickels, plus h, the number of half dollars, equals 18. And there's one nice little easy equation to work with. We're going to have to set up another equation, though, because this is not enough to solve for n or h by itself. So we can also have an equation talking about the value of the coins, adding up to $4.05. So the value of the nickels plus the value of the half dollars needs to add up to $4.05. So the value of the nickels, and I'm going to do all this in terms of cents just so I can avoid decimals. So that's going to be 5 cents times the number of nickels, 5n. And we're going to add to that the value of the half dollars, which is going to be 50 cents times h times the number of half dollars. So 5n plus 50h, and again that should equal 405, and I'm going to write 405 because this is all in terms of cents. All right, so now we're going to solve. You could use substitution or elimination here. I think, well, I always go with elimination, but substitution actually works just as well if you isolate the n or the h on this. But I'm going to use elimination, so let me multiply this equation by negative 5, so that I can get a negative 5n and cancel out this 5n. So we have negative 5n minus 5h, and you could have multiplied by negative 50 if you wanted to cancel out the h's, but we're here now. We got 5 times 18, that's going to be 90, so negative 90. Adding these equations together, we've got 5n's canceling out. The h's, that combines to give us 45h on the left. On the right, that's going to be, let's see here, 315 there. There we go. And I just happen to know, because I work with multiples of 45 a lot, that 315 divided by 45 happens to be 7, but you could do that on a calculator. So that's 7 half dollars we're dealing with. To find the number of nickels, we just plug that 7 for h back in, and this is a good equation to use right here. So we've got n plus 7 equals 18. Subtract 7 from both sides, and we end up with 11 nickels. On this one, we have Anthony with 28 coins, quarters, and dimes that add up to $3.10. How many of each type of coin does he have? So let's start by defining some variables. We'll say that the number of dimes will be represented by D, and for number of quarters, we'll use Q. Now I'm going to set up two equations, one talking about the number of coins, another talking about the value of those coins. We know that the number of dimes, D, plus the number of quarters, Q, has to add up to 28, because Anthony had 28 coins, no other types. And then the value of those coins has to add up to 310. So the value of the dimes, that's 10 cents times D times the number of dimes, plus the value of all the quarters, that's going to be 25 cents times Q. All that has to add up to $3.10. So I'm going to write 310 just so I have everything in the same units. If I'm doing 10 and 25 here for cents, I need to do cents on the right side as well rather than dollars. All right, time to solve this system of equations. I can do that with substitution or elimination, but I'm going to use elimination. I always do that in this situation here. So I'm going to get rid of the D's. I'm just going to multiply this first equation by negative 10 so that I have a negative 10D that'll cancel out with the 10D from the other equation here. And then I also end up with a negative 10Q minus or equals negative 280. Adding those equations together, the D's are gone, leaving me with, let's see, 25 minus 10, that's 15Q on the left side. On the right side, 310 plus negative 280, that's 30. And then dividing by 15, we get Q equals 2, so that's 2 quarters, only 2 quarters. How many dimes? So let's plug 2 back in for Q in this equation over here. So we have D plus 2 equals 28. Not a bad equation to have to solve, right? Subtract 2 from both sides, and we end up with 26 dimes. On this problem, we have 2 records and 3 tapes costing $31 and 3 records and 2 tapes costing $29, because that's not confusing. We want to find the cost of each record and each tape. So let's set some variables equal to the things we're trying to solve for. We'll say that the price of a record is going to be, we'll say R, and then we'll say that T will be the price of a tape. So we're going to set up a couple equations here. If 2 records and 3 tapes costs $31, we can set up an equation with that. So we have the value of the records plus the value of the tapes equaling 31. The value of 2 records is going to be 2 times the price of a record, so 2 times R. The value of the tapes here is going to be 3 times the price of 1 tape, so 3T, and we're going to add that in there. And that should all add up to, should equal 31. My other equation I'm going to set up pretty much the same way. We have 3 records this time and 2 tapes, so 3R plus 2T equals, and this time around it's 29. So for this one, you could use substitution or elimination, but substitution is going to be kind of nasty. It's going to involve fractions no matter how you do it. So I'm going to go with elimination, and I'm going to choose to eliminate the R right off the bat. So the 2 and the 3 that are coefficients of R, the common multiple there is 6. So I'm going to make one of these 6 and one of these -6. So let me start by taking this equation here and multiplying that whole thing by 2. So that gives me 6R plus 4T equals 59. And now to get a -6R from this equation, I'm going to have to multiply this first equation here by -3. So that's -6R minus 9T equals -93. Adding these equations together, the 6R's cancel. 4T minus 9T is -5T. And on the right side, 58 minus 93, that's going to be, let's see here, 35. -35, yep. And then if I divide both sides by -5, we end up with T equals 7, which means the price of a tape is $7. These must be like 1980s prices or something. Okay, let's go ahead and find the price of a record. Well, I don't know. If there's records, it probably isn't even the 80s. It's probably like the 60s or the 70s at that point. So we've got T getting plugged in, 7 getting plugged in for this T over here. So we can write 2R plus 3 times 7 equals 31. 3 times 7 is 21. Subtract that from both sides, you've got 10 on the right side. So that means 2 records gives you a price of $10. So dividing by 2, we have 1 record costing us $5. For this problem, we have Barney, maybe not the dinosaur, I don't know, with 23 coins totaling $8.50, and this is comprised of half dollars and quarters. How many of each does Barney have? Let's set some variables equal to the things we're solving for. So for quarters, we'll let Q represent that, the number of quarters, and for half dollars, we'll use H. So this is the number of each type of coin. We can set up an equation talking about the total number of coins. If I take all the quarters, which is Q, and add to that the number of half dollars, H, that should all add up to this 23 they gave us. And we can also write an equation talking about the value of the coins. If I take the value of all the quarters, which is 25 cents times the number of quarters, times Q, 25Q, and I add to that the value of all the half dollars, so plus 50 H, because there's 50 cents in half a dollar, that should all add up to 850 cents. I have to have everything in terms of cents or everything in terms of dollars, and if you do it in dollars, you're going to use decimals. All right, time to solve this system of equations. You could go with substitution or elimination. I'm going to go with elimination, though. I'm going to multiply this first equation by -25. That'll give me a -25Q that I can cancel with this 25Q, minus 25H equals, well, let's see, what's 23 times 25? I'm going to do this on the calculator just to be safe. That ends up being 575, okay? And that's negative because we had -25 times 23. Adding those equations together, we've got those Q's canceling out, and 50 minus 25, that's a little bit easier. That's also 25. h. And let's see, 850 minus 575. Let me go back to the calculator. I feel like I'm going to use it a few times. So we got 850 minus 575, and that comes out to 275. And then we have to divide that by 25. Might as well just keep going the way we're going here. Answer divided by 25 gives me 11. So that's 11 half dollars we've got. And it's a little bit easier to get the number of quarters. Just plug 11 in for h over on this easier equation over here. You could use this equation, but I mean, why bother? This one's a lot easier. We've got q plus 11 equals 23. Subtracting 11, don't need a calculator for this. Q is going to be 12, so that's 12 quarters.